Welcome to Get Started with MATLAB and Simulink, an intro for beginners. This course is designed to teach complete beginners how to get started using MATLAB and Simulink. Now I'm going to tell you a little bit about me. My name is Jordan Chrisman and I'm the instructor for this course. I have my graduate degree from the University of Dayton in electrical engineering with a focus on embedded systems, where I typically worked with FPGAs, microprocessors, and any type of logic system with low-level voltages. I am an avid Pittsburgh Steelers fan. I try to watch every single game that is televised, and so if the game is on, you most likely can figure I'm watching it or catching updates on my phone or online. I use MATLAB and Simulink every day at work, and I have found it to be a very powerful and extremely useful tool. And I like using it so much that I enjoy teaching about it, and I want to be able to teach you how to use MATLAB and Simulink and show you the powerful capabilities that this tool has. If you're working on any cool projects using MATLAB or Simulink, or if you have any cool project ideas, absolutely let me know. Like I said, I enjoy doing this, and so if you have any cool ideas, let me know, because I'm always interested to see what other people are doing or how they're using MATLAB and Simulink. And if you have any questions regarding MATLAB or Simulink, don't be afraid to ask. Just send me a message or a question or an email and ask me any type of questions you have about MATLAB or Simulink. In this course, let's talk about what you're going to learn. This course covers introductory topics relating to MATLAB and Simulink. And the big things you're going to get, you're going to learn how to get MATLAB set up on your computer. So we're going to show you step by step how to get everything you need to get MATLAB up and running on your PC, which this will include. We're going to show you how to create a MathWorks account, which is what you need to download and install the software. And also I'm going to show you how to download and install the software and to set up the licensing, as well as how to run the program itself. I'm also going to show you various different things and aspects about MATLAB, such as the command window, the workspace, as well as the script editor. And the course itself, the contents, is laid out in such a way we have basic MATLAB commands and features, and we're going to review the Simulink environment and features, and a quiz, and then the student assigned project. And the course will start out explaining how to download and install MATLAB and Simulink through step-by-step instructions. So these are very detailed instructions that are going to show you here's what you need to do step by step in order to get MATLAB and Simulink up and running on your computer. And the next section, we're going to cover just the MATLAB environment and the different features and how the different features are used. So these are kind of the very like the command window, workspace, the script editor, all the various major features of MATLAB that in order to learn MATLAB, you have to understand what the different features are, and when someone says in the command window type this, you need to understand where the command window is and how it works. There also is a quiz that will test your knowledge on the basic MATLAB information. So if you pass this quiz, that lets you know that, okay, you have a pretty basic and good understanding of how MATLAB works. And there is also a project that will require you to complete a task in MATLAB. Now that you know what to expect from this course, let's get started with MATLAB and Simulink, an intro for beginners. Welcome to the Creating a MathWorks Account lecture. In this lecture, we are going to perform the first step of downloading and installing our MATLAB and Simulink. The first thing we want to do is create a MathWorks account. So if you click on the link that is attached as a resource in this lecture, it will take you to the MathWorks account website where you can create or log in with your MathWorks account. If you already have a MathWorks account, then you can go ahead and skip this lecture. You don't need to worry about it. If you do not have an account, you want to click on Create Account. And the first step is you have to enter your email address. And this is the email that they will send you a verification as well as most likely a license. So put your personal email in there, and then you need to select the country or region wherever you're located. And how will you use MathWorks software? Select one of the few. I'm going to say personal, non-commercial projects. That's because we're going to be downloading the home version of MATLAB, so we cannot use this to produce goods and resources to sell. This just has to be for our personal use, non-commercial use. Otherwise, you have to pay for the commercial license. And are you at least 13 years or older? Yes. And then select create. And here, they're going to send an email to your email address, and we need to verify that our email address is valid. So you'll want to open up your email, whatever email address you told it to send to, and you want to verify that you get your actual email. So you'll just kind of wait, and eventually it's going to come through. And once they send you the email, you'll click on the link, and we will be verified. In order to make sure the email actually appears in your inbox, it may show up in your spam. So in my email account, in my spam folder, I have this service that says verify email address. So if I open up the email, it says, thank you for registering with MathWorks. To complete registration process, verify your email by clicking the link. So we'll click on this right here, and this is just used to verify your MathWorks account. And so now we need to finish creating our profile with the following information for your email. So you want to type in all of your personal information, like your first name. You want to give it your last name. And user ID, this is optional. I'm going to leave mine blank, but that's totally up to you. And then you want to create a password. So you'll type in a password you'd like to use, and then confirm your password. So you'll have to type it in again. Another password you're comfortable with using. And it'll give you a little green checkbox to let you know that your password has been verified. Now, if you've already purchased or downloaded MATLAB or already have an activation key, this is where you will input that information. However, at the moment, we are just creating our account. We haven't actually purchased MATLAB, so we don't have an activation key or a license to associate with our account. So we're just going to leave this blank. And if you want a sales representative to contact you, you can check this. That's totally up to you. I'm going to leave it unchecked and click create. And now I have my profile where it gives me my name. I can upload a picture and do this and that and the other things. You can kind of go around it and input all this other information if you'd like. But the key thing we're going to need to do is after we download and purchase MATLAB and Simulink, we're going to need to associate a license to our actual account to verify it. And so when we get to that stage, I'll show you how to do that. But for right now, the big thing is you just need to create a MathWorks account. And the important things to remember on that account are the email address you used, your personal or whatever email address you associated your MathWorks account with, as well as the password. Those are the two key important pieces of information you need to make sure you saved. Welcome to the step 2, where we're going to purchase and download the MATLAB and Simulink software. So if you go to the link that I have provided in this lecture, it will take you to the MathWorks website where it goes over the pricing and licensing. And I'm going to select the home version. If you're a student, you can select the student version. If you're currently in school, you'll be eligible for that. Or the education edition as well if you work at a university. And if you're a business or you're a company, you'll need to purchase the standard edition. But if you're anyone else, for most people, you'll just select the home version. And so now we want to click on the Buy Now. And this is going to take us to the latest version, which currently is release the R 2017A. So that is the version that we are going to download and install, so we'll get a license for that. And if there is, depending upon what the latest version is, if it's 2017B or if it's 2018 or 2019 or so on and so forth, go ahead and download the latest version. Everything that we cover in this course, I'll be using release 2017 or 2016 in that range there. So anything that's later than that will be supported. So you don't need to worry about having, if your version is different than the one I have, that should be relatively similar. All the commands for the scripts and everything else will be the same. So what we want to do is select what we want to purchase. So we need to purchase MATLAB. That is a must. So we need to check that box, which that's $149 US. And then they have all these different toolboxes, where in this course, we're not going to be using these toolboxes, where you can see each toolbox is an additional $45 US. But that's a lot of different things you can do with MATLAB are associated with these different toolboxes. So you've got your math, statistics, and optimization, parallel computing, your control systems, and your signal processing and communications. So all depending upon what you really want to get into, after you take this course and understand really how MATLAB works, you can go out and start buying some of these toolboxes and playing with them to get an understanding of how they actually work. So the only two we are going to use is we want the actual MATLAB, which you need, and then we want to get Simulink. So if we go down, and there should be the Simulink product family, we want to just get the standard basic Simulink. And Simulink also has additional toolboxes: SimScape, Event for modeling, control systems, real-time simulation, graphics, so on and so forth. So what you should see is we have two boxes checked, the MATLAB and the Simulink. So now we want to go to Proceed to Checkout, and we have two items. We have MATLAB as well as Simulink. And at this point in time, I'm currently signed in. So if you look up in the top right, you'll see where it says Jordan, my account. That's because I'm signed in, so it's letting me get to this point. If at any point in time, if you're not signed in, when you click on this link, depending upon the computer you're using and what your settings are for your browser, it may say that, hey, you're not logged in, you need to log in. Well, that's where you'd enter your email that you use to set up your MathWorks account, as well as the password you use to set up your MathWorks account. You'll put both of those into the prompt that it tells you, and then it should bring you to this screen. So at this point, it's just telling me everything I have. I've got MATLAB and Simulink, and my subtotal is $194 US. So now I want to go to Checkout, and you have to agree to the terms and conditions. So I want to click Continue, and we need to provide this information. So the address of use. You want to apply the address where you're going to be using it. Where's your home computer? Or if you're using a laptop, where is your laptop the majority of the time? So this would just basically be where you live. And so you'll fill all the information out. So once you have all the information filled out for your address, you will then click Continue. And this will bring up the billing information. So at this point, if you're most likely going to have to use a credit card, so you'll want to put all the information that's required for your credit card. So you'll fill all this information out. And once you have all of the billing information filled out properly, you will then want to select the Continue. And this will bring up the payment information. And in here, we need to import the credit card number and the expiration date and security code, or your validation code for your credit card. Once all of the payment information has been inputted, you'll click the Continue button, and it's going to verify all your information. And then here, we are brought up a screen to say Confirm the purchase. Just gives you all the information, and the key thing we need to look at is the products. We've got MATLAB and Simulink, and the total, which US dollars is $208, so submit my order. And so here, they're giving you that the purchase has been confirmed. We have confirmed the purchase of our order. So now what we want to do is we want to click on the download your products now. So we'll click on download products now, and so this is where we're going to download release 2017A. However, we could go and use an older version if we really wanted, but I'm going to work with 2017A, and if we have an issue with it, then we'll switch over to an earlier version. So we'll click on the link to download, and here we need to choose the installer. So I am running on Windows, and it's a 64-bit machine, so I want to do the Windows 64-bit. And here you can see in the bottom left-hand corner, it brings up this MATLAB R 2017A Win64.exe. This is an executable that after it has been downloaded, I can run to install the MATLAB. Once you see that the download has completed, you'll see in the bottom here that the logo appears. So we can now click on it, and it'll tell us we're opening MATLAB.exe. Welcome to step 3, where we are going to install MATLAB and Simulink. So now that you've downloaded the MATLAB installer, which is this MATLAB _R 2017A Win64.exe file or application, and you can go ahead and double click. It's an executable, and it'll open up and try to give you WinZip extractor. Now, if you're running in Windows 10, which I am, you'll notice you'll get this error where it says could not create temp MATLAB R 2017A Win64/help/includes/product/images/MATLAB_GS. Unzip operation canceled. And if you click OK, then this WinZip self-extractor will just go away. Now, if you're in Windows 7 or Windows 8, you may be able to just double click on this and have it pop up and run right away. If you cannot, what you want to do, so go ahead and click OK, and we're going to take and drag this application to our desktop. And then we'll go ahead and just double click it right from our desktop. And then at this point, you should just, it'll go ahead and run. You'll see your computer's going to come up with a little window that says, do you want to allow this app to make changes to your PC? We'll click yes, and it's going to run through the installation. So once you get to this screen, you'll know that your installer is working properly. So we want to select the login with a MathWorks account. And just make note, this requires an internet connection. So if you already were able to download the MATLAB and Simulink installation file, then you have a valid internet connection. And so this will work just fine. And we'll click next. And you'll want to go through and make sure you read the license agreement. And select yes, hit next. And this is where you want to log in with your MathWorks account. So as I mentioned before, the important things you need to know are the email address and the password, which these are both what you set when you signed up and logged in with the account. And then you want to type in the password. And this is going to go out and verify your MathWorks account and associate your license. So create a MathWorks account, which we already have a MathWorks account, so we go click next. And here we need to select a license. So since we purchased the MATLAB and Simulink license, it picks from our account and knows which licenses we have. And this is the only license I have, is this this license here, which is a home individual. And you'll click next. And now it's going to go out to the MATLAB's website and select and verify you have a license. And we're going to say choose installation folder. I'm going to leave it all default, so we'll say next. And the products, we only have 2, MATLAB and Simulink. Click next. And add shortcuts to, I'm going to add them to the desktop. and we will say next. And these are giving us our information. So just the installation folder, the download size, and the installation size. These are important to know. Make sure you have enough space on your computer to do so. And we'll click install. And so from here, you'll see that it's going to go out and pull the files that it needs in order to download MATLAB. So you'll see we've got downloading MATLAB 9.2, 23 of 1055 megabytes. And we're at 0%. So depending upon how fast your internet speed is and how fast your computer is, this can take a little while. So I would suggest at this point, we are going to say this is complete. And once we go through this here, this entire process, once we're 100% complete, at that point, you should have the MATLAB executables on your desktop and be able to open MATLAB. So that is how you install the MATLAB and Simulink on your PC. Hello, and welcome to step 4, verifying that your MATLAB and Simulink download has installed successfully. So we've created our MathWorks account, we've downloaded and installed the MATLAB and Simulink, as well as purchased the license. So now we just want to double click on the MATLAB R2017A link on the desktop. So when you double click on your MATLAB desktop, you should see a little splash screen that appears, and then your MATLAB home use pops up. Now, it'll give you a little indicator, and close it out. You'll see a little indicator in the command window. It says home license for personal use only, not for government, academic research, commercial, or other organizational use. So this is just kind of a little home license letting you know that this is a license you have. Now, what you want to do is, as soon as your MATLAB pops up, you want to type in VER and hit enter. And what this will do is bring up the information about the specific MATLAB version you're using. So in my case, I have MATLAB version 9.2.0.556344, or it's the release 2017A, and I have your MATLAB license number. The operating system, I'm using Microsoft Windows 10, home version 10.0, build 10586, and it also displays the Java version. Your MATLAB and Simulink run off of Java, so it will display the Java version you have, and it shows the two licenses or toolboxes that I have. I just have standard MATLAB version 9.2 and Simulink version 8.9. And so if you were to purchase any additional toolboxes, you would see them displayed in the command window as shown. And if you'll notice that in your documents directory, it'll create a folder called MATLAB. And in there should be two files, a plot_wave.m and a chirp_wave.slx. The chirp_wave.slx is a Simulink file. So if we double click, it'll open up a Simulink file. Now, we'll see this just creates we have a chirp signal waveform and a to workspace, we're calling it Y, and we have a clock and to workspace T. So if we click run, this is just taking the chirp signal, the Simulink block, and applying those values into a workspace. So you'll see we have this Y value, Y in our workspace. Now what we want to do is click on this plot_wave.m, and this brings up the editor. And I can pull this out so it's in a separate screen, but this is the .m, the script editor. And we will cover these more later, the Simulink as well as the script editor. We'll cover them later, so don't worry into the details of how these are working. I'm just wanting to show you this so you can verify that your MATLAB opens, you have the right version, and you're able to simulate and run all these different options here. So what we want to do is click on the run, and what we're going to do is generate a figure, and we're going to plot the T and the Y. Basically, we're just going to take this chirp signal that we created, the Simulink block, and we're going to plot it. So we'll click run, and this should bring up a little image that's called figure 1. We have X label and Y label. And this is here to show you that you can type whatever you want in there. So your X label would most likely say time, and your Y label would be like amplitude or so on and so forth. So it just basically generated a chirp signal that goes from 1 to -1. And as time increases, the frequency increases as well. And so that is a quick demonstration just to show and verify that your MATLAB and Simulink have installed, downloaded, and are working properly on your computer. Welcome to the MATLAB Environment Overview lecture. In this lecture, we're going to cover various aspects of MATLAB, including the command window, the workspace, the script editor, the variable editor, as well as other tools that you can use to plot variables and all sorts of different things that you can do with MATLAB. This is just an overview to get you comfortable with the environment of MATLAB. The first thing we'll start out with is the command window. The command window is where you can type different commands that you can do all sorts of things with MATLAB. So for example, I'm just going to type a command, a equals 4 semicolon. When I press enter, you'll now see, we'll bring up the next part, our workspace. I have the value of a, and it's equal to 4. And that's just in my command window, I made a equal to 4. So now I'm going to make b equal to 5 in my command window, hit enter. And you'll see in the workspace, b is equal to 5. And that's just an example of the command window. We'll go over this a lot further in more detail, but this is the place where you can type different all the different MATLAB commands you can type in this command window, and it'll execute them as soon as you press enter. Which then brings up our very next portion of MATLAB. We have the workspace, where you can see in our workspace we have A and B, and these are both variables with the values 4 and 5. When you hover over them, it gives you details. It says a 1x1 double. That's just the data type. You can specify them as singles, doubles, or 32-bit integers, so on and so forth. All the different data types associated with computers. Now, in the workspace, we can edit these. So if I double click on the A, it brings up the variable editor. So I can make this value 4. If I double click in the variable editor, I can type in a different value, say 6, press enter, and if I click out of the cell where the 6 is located and X out of there, you'll see A is now equal to 6, where in the command window we made A equal to 4. By using the variable editor, we were able to make A equal 6. And that is how you can work with the different variables in your actual MATLAB environment. So as you're running different scripts or doing different commands, all the values and the variables you're working with will show up in your workspace, and you can see the name that's associated with them as well as the value. So if I want to save these variables or save this workspace, these are some of the commands we have on the Home tab. So we have the Save Workspace. If I click on Save Workspace, it's going to take the A and B, these values of 6 and 5, and save them wherever I specify in the .mat, a mat file. And it's just like a binary file that I can open up within MATLAB, and we'll know that, okay, we have a variable A, which is equal to 6, and a variable B, which is equal to 5, into my workspace. And so we'll go ahead and cancel out of that. You can also do this by saving specific variables. So A, I can right click and do a save as, and it brings up the same window. Now this will just save the value A, where previously when I did save workspace, that would save all the variables that are located in the actual workspace. And I'm just going to go ahead and we'll save this value right here. We'll just call it matlab.mat, say save. And so now if we look in our folder, which is a directory structure of where we're located, we can click on the Browse for Folder button to go to a different folder inside your computer. So I'm just going in my standard MATLAB, so cancel out of there, standard MATLAB folder in my documents, where I have 𝐒𝐸𝐴𝐷 examples, projects, thermistor calculations, and several other MATLAB files. But if I go ahead and delete my A, I'll say okay, delete that. Now if I double click on my matlab.mat file, you'll see the command is run in our command window, load matlab.mat. And as soon as I ran that, we'll see that the A value in our workspace came back. And that's because we saved it. So that's a way you can save your workspace values if you want to come back to them later and you want to close out of MATLAB, but you already have these variables with certain values. This is a good way to do that. And so that is kind of covers the whole command window, the workspace, and then we have our file structure on the left where it says current folder, and it shows you all the different MATLAB files. We've got these .m files, which are scripts, and so I'm going to show you and introduce how do you create a script. You can create a script, which we're just going to cover this very briefly here. Click on the new script, and this just brings up the script editor, where in this untitled part you can type in, I'll type in percentages, which are comments, and we'll cover this in more detail. And you just type in different MATLAB commands. So you can say A is equal to 5, semicolon, and we can save this. We'll do a save as, and we'll save it in the same location. Just call it my script, my_script, save, and I'll close out of it. So now I have a myscript.m, which is just effectively a MATLAB script, and it recognizes the .m files as a script. And so I can go now, I can either A, click on the new script button, or I can right click and open, and now it opens that script in the script editor. The script editor has various different commands. You can save, open a new script, open new documents, you can print, compare files, all different kinds of functionality. You can set breakpoints, you can insert comments, you can indent, check your functions, run, and all sorts of different stuff. But whenever you're writing MATLAB scripts, you're going to use this script editor. So we'll close out of that.
And the next thing we're going to go through is just cover the different tabs that we have. So when you look at your Home tab, you'll see you've got a File, Variable. I have Code, Simulink, Environment, and Resources. And depending upon the toolboxes you have, this will vary. So the code, if you have depending upon whether you have the C code or embedded coder toolbox, you may or may not see these different commands. So don't worry if you don't see all of these on here, you just probably don't have all of the toolboxes. Or if you have more, it means you have more toolboxes than I currently have loaded on my MATLAB. And if you go to the Plots tab, this shows you all the different plots that you can do through MATLAB. So if I pull down, click on the down arrow, this will show you all the different possible MATLAB plots. We have favorites, MATLAB inline plots, MATLAB stem and stair plots, and so on and so forth. They have all different kinds of plots in MATLAB, and that's what MATLAB is very powerful at doing. So we'll X out of that, and then we'll go to our apps page. This is going to depend upon the toolboxes you have as well. So different toolboxes have different applications that can do different things. So like I have here a filter builder and a filter designer, window designer, and fixed point converter. And all depending, as before, depending upon the toolboxes you have loaded, you will see different apps available. And so this is just a quick overview of the MATLAB environment and the things that you'll see when you open MATLAB, just to kind of get you started.
Hello, and welcome to the command window lecture. In this lecture, I'm going to show you how the command window is used in MATLAB. So the command window is an interactive way to, basically you can put equations in here, you can make plots from here, you can do all different things. Anything that you can put in your MATLAB script, your .m file, you can also put in your command window. And so for example, we're just going to run through a quick little example here, and this will give you a pretty good idea of how the command window is used. And all throughout this course, we will be using the command window. And as you use MATLAB, you'll come to find out that the command window is very valuable for all sorts of things. And one of those things especially is when you're creating a complex or longer script, it's a great way to quickly verify if your equation or the line that you have in your script is evaluating to what you would expect it. So for example, we're going to take a variable called a, and we're going to make a equal to the value of 4. And then I'll put a and hit enter. And so as soon as I do that, we can see in the workspace we now have this name, it's a variable a, and it's equal to the value of 4. Now, as soon as I hit enter, you see that we have this a equals 4. Now, if I do my b equal to 5, I'll put a semicolon and hit enter. And then we'll see that my b value is now equal to 5. And so by putting the semicolon, we'll see that the b value is no longer displayed in our command window. And what that is it's called suppressing your output. So from this command b equals 5, the output is we create a variable b and it has a value of 5, but we suppress the output. So we still have a variable b and it's equal to 5, but we just suppressed it. So on this a equals 4, if I were to put a semicolon there, the a equals 4 would have no longer been displayed on the command window. And so now that I have these variables, another thing to note, and we will get more into this when we talk about variables and programming, but it is case sensitive. So I can have a variable lowercase a equal to, we'll say 7, and we'll suppress the output. So now we see we have a lowercase a, which is equal to the value of 7, and a capital A, which is equal to 4. And what I'm going to do, we're just going to go ahead and delete the a. So we'll do a command clear a, and we hit enter. We'll see that the lowercase a is removed from our workspace. So now we only have a and b. And so now these are the values that we can use to do different operations with. So for example, we'll do very basic. We'll say a plus b, and if we don't suppress the output, it'll display it. And automatically, if we don't create a variable called ans, short for answer, is created. And our ans is equal to 9, which makes sense because we have our a, which is 4, and our b, which is 5, 4 plus 5, is equal to 9, and it gives you the value a and s. Now, we can do the same exact command, and if we push the up arrow key, it gives you a history of all the commands that we've created. So we're pressing the up arrow key on your keyboard, I can click the a plus b, and now, instead of hitting enter, I'll make it a variable called result is equal to a plus b. Now if I hit enter, result is now equal to 9. And we still have the variable a and s. So if we do another one, let's say we take a times b, and we'll suppress it, hit enter. Now we'll see that our a and s is equal to 20. That's because 4 times 5 is equal to 20. But our result is still equal to 9. And that's because our result is equal to a plus b. And we can do all different types of math operations. So I can take my a divided by b and hit enter. And the answer is 0.8, which makes sense. Our a is 4, our b is 5. 4 divided by 5, 4/5 is 0.8 or 80%. And I can do my a minus b, all our different standard operations, minus 1. We can also do slightly more complex, and we will cover this in the basic commands and equations section. So we'll give you a whole list of all the different MATLAB commands you can do, but all these commands can be typed in your command window. So for example, we're going to talk about square root. Now, a way to tell if the command is correct or not, we'll just start by typing, so SQRT is for square root. And as soon as I put the open bracket on it, you'll see that we have this SQRTX. That tells us that we put a value in there and it'll give us the square root of it. But if we click on the more help, or you can search this function on Google and type in MATLAB square root function, you'll find this. But what this tells me is that it's supported. So for example, if I do this all caps, SQRT, open parentheses, it's saying cannot display function hint and cannot parse function reference, page, or MATLAB function code. What that means is it does not recognize any function called capital SQRT. So what I could do is I could create my own MATLAB function, and we'll cover that later in another section. But this is telling me that, hey, whatever you put in here, this is not a recognized function by MATLAB, so it's not going to work. So we'll go back to our SQRT, open that up, and we'll put a value in there. So if we put our a plus b inside of our square root, we'll hit enter, and the result of this will be, it'll take our a plus our b, which will give us a value of 9, and the square root of that is 3. And so we get the result of 3. And so you can do all different types of complex. I can even just type up a crazy one here. We'll say a plus b times a plus result, and we'll hit enter. The answer of that is 33. So a plus b times a plus result is equal to 33. And so that is how you can use the command window. And so it's a great way to type up, do quick little math commands, or anything you want. And also, another quick little hint, quick command, which we'll cover later as well, but we can do the CLC, which is clear. And what that does is it clears the command window. So as soon as I do that, everything that I had displayed on my command window goes away, but my workspace still stays the same. If I want to get rid of my workspace, I type in the clear command. So clear, and then I can do CLC. Now I'm back to square one. And so that is a quick way that you can use the command window. And like I said, throughout the rest of this course, we're going to be constantly using the command window. So this is just a brief overview of how you can use this. Welcome to the Workspace lecture. In this lecture, I'm going to explain and show you how the workspace is used in MATLAB. So the workspace is the window that is shown on the right, and what the workspace shows is all the variables that you're currently using. So when you first open MATLAB, you'll see that the workspace is empty, and that's because there's no variables. And so in order to put a variable in the workspace, you either A, when you run a script, it'll generate variables that will then be displayed in the workspace, or you can generate them directly from the command line. So here at the beginning, I'm going to put them in there directly from the command line. So let's create a variable. We'll call it example. We can name it whatever we want. Example is equal to the value of, we'll say 1024, and we'll suppress the output so it doesn't display it. Now, by default, if I hover over example in the workspace, you'll see it says 1x1 double. What that means is the 1 by 1 just means that it's a matrix value of 1, and double means that the data type is double. And that's important to know. By default, MATLAB variables, if you don't give them any name, they will default to the variable value of a double. So in order to, let's say, have it a different value, let's create, we'll call sin underscore example is equal to single, we'll say 1024, and suppress the output. So now we have a variable called sing example. If we hover over it, we see 1 by 1, but it says single. Now example says double. And all that is just the precision of that variable. So for example, the sing underscore example is a single precision floating point value. The example is a double precision floating point value. And so it's just, that's a 64-bit value, and that's a 32-bit value. Now if I want to display them, I'll just type example and no semicolon, enter. I can see example is equal to 1024. If I say sing underscore example, and if I hit tab, it'll finish it to give me the only options I have available. Sing underscore example is the only thing I have available to select, so hit enter. Now you'll see that our sing example is still equal to 1024, except it's a single precision data type. And when I hover over it, you'll see that we have the little pointer finger. We can click on it, and that'll bring up the help window of MATLAB to explain what this is. This is convert to a single precision. And if you read through, it gives you a description and some examples and ways in which you can use it. So floating point numbers, so on and so forth. There also are a lot of other different data types we can work with. We can do integers, characters, and so one of the examples I'll give you is a character array. So we'll say our hello variable is going to be equal to hello example. And by putting single quotation marks, if I enter, you'll see that hello is equal to hello example. And this is a character array. So if I double click, we can see that it's a 1 by 13 character array. And I can click on the character to bring up, a help window explaining what a character is, but I can go directly into this variables editor and I can edit this variable if I want to, but I'll close out of it. And we'll also say, so we have a character array, but we also have another thing called a string. So I will say, call it my underscore string is equal to, we'll say, this is a string, double quotations. And the only difference is we have a double quotations versus a single quotation. And this is only starting in MATLAB R 2017A. So if you're using an older version, this won't work. But if you go with my string, now if I hover over it, you can see it's a 1 by 1 and it's a string value. And so in the workspace, it tells you the name, the value, as well as the data type and what, if it's an array, so, or if it's a string, or if it's a single data type, whatever it may be. Now, we can also create an array. So I'll call this array is equal to, and I'll give it an open bracket, 1, 2, semicolon. And the semicolon means that you go to a new line. So 1, 2, 3, 4, and we'll end. And I'm going to hit enter. And now we can see, since I did not specify the data type, this is an array of 2 by 2, and it's a double. And we can see the values. It's a 1, 2, 3, and 4, just like we specified. Now also, within the actual workspace, we can also change the value of these variables. So as an example, we'll go with the example is 1024. And if I type example, we see that it's equal to 1024. Now what I can do is double click on example, and it brings up this variable examples editor. So I can go in here, and this 1024, I'll make it 2048. And if I click out and close, my example is now equal to 2048. So if I click the up arrow on my keyboard and hit enter, example is now equal to 2048. And I just changed that value through the variable editor. So that's one of the capabilities you can do. You can delete variables from within the workspace, and that can be done by right click, delete, and are you sure I want to delete the selected variable? And I'll select OK. So now example no longer exists. If I try to type, if I would type example right here, just like I did on my previous command, hit enter, it says this is an undefined function or variable example. It doesn't exist. It doesn't know it's there. The workspace is where all the variables that MATLAB is aware of and that you can use all correspond and live in the workspace. So another thing we can do, we will create, if we go in our array, or we'll create another value. We'll call it just a test. This is equal to, we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Enter that. Test. So now we see our test is a vector of a 1 by 10. So if we open up test, we can do this command transpose, where if I transpose, it's now a 10 by 1. And I can transpose, it's now a 1 by 10. And so this is one of the different things we can do inside the variable editor. I can also go in here and change these individual values. I can make this 5, 7, or any value I want. And if I close out of there, you can see my test is now 1, 2, 3, 4, 7, as opposed to 5. And that is kind of just an overview of what you can do in your actual workspace. So just by hovering over the value, it tells you the data type and the structure of 1 by 13 character. We have a 1 by 1 string, a 1 by 1 single, and a 1 by 10 double. And by default, MATLAB, unless you define the actual value you want it to be, it's going to default everything to be a double. So that is a quick overview of the workspace in MATLAB. Welcome to the Script Editor lecture. In this lecture, I'm going to show you how to create, save, and run a script that you have created. So within the current folder, we can see we have this script plot_wave.m. And in MATLAB, scripts are denoted by the .m extension. So in order to create a new script, we will click on the New Script button. And this brings up the script editor. So within here, we'll type our script, and we can then save, or we can open a new script. You know, you can insert comments. There's all kinds of different tools and things we can do. We can run. We have a publish where we can publish it in line with tech, and a whole bunch of different things we can do. So the first thing, we're just going to create a very basic and simple script. So first thing, we'll put a comment, which is denoted by the %sign. So I'll say this is a comment, and we'll enter down. Now what we want to do is we want to save our script. So if we go to click the Save button, it'll bring up the Save As editor. So it's going to put us in your PC, My Documents, MATLAB folder, which we're currently located in. And the options we have, we can give it a MATLAB live script, all files, but we're going to go with a MATLAB code file, which is the .m. So I'm going to give it the name, just call it example. So this will be example.m. We'll save. So now we can see we have this chirp wave.slx for a Simulink file. We have example.m for the script we're creating currently, and the plot_wave.m for the script that came with our MATLAB download. So within here, we have, okay, the first thing we're saying is this is a comment, and we'll now say A is equal to 1, and we will suppress that. B is equal to 2, we'll suppress it, and we'll say C is equal to 3, suppress the output. D is equal to 4, and suppress the output. Now, what we can do, another thing is we can create these sections. So when you have a very large script, it may make sense to have multiple sections to kind of break things up. So when you're testing, you've got the run, we can run the entire script, or we can do the run section, which will run the current section we're in. So in order to create a new section, you do 2 comments in a row. So since we did 2 comments, you can see it inserts the line. So now we'll call this display our variables. And what we'll do is we'll display our A, B, C, and D. But before we do that, we have this is a comment, we'll call it that, but we'll say initialize variables. Initialize the variables. And in our initialize variables, we are obviously initializing A, B, C, and D. So if we hit save, the save icon then goes to gray, showing that our value is saved. And if I hit the run section, we'll see that since we suppressed our A, B, C, and D, we have no output on our command window. But now in our workspace, we have these values A, B, C, and D. So now, in order to run the second section, we'll say A, B, C, and D. Now this will display our variables A, B, C, and D. So if we hit save and run section, we now have our command window shows A is 1, B is 2, C is 3, and D is 4. And so now we can create a new section we'll call math, where we'll just do some math. So we'll say sum, the value sum is equal to A plus B plus C plus D, and then we'll have our multiplication is equal to A times B times C times D. Well, actually, we'll call that the product because we're multiplying all of those. It makes more sense. Call that product. So we have our sum is equal to A, B plus C plus D. Our product is equal to A times B times C times D. Now, if we highlight over the equals, it'll give us a little warning saying terminate statement with a semicolon to suppress the output within a script. Now, we want to leave it non-terminated because we want to display the sum and product. So what we can do is do our run section. So we see our sum is 10 and our product is 24. Now, if we wanted to, then let's go ahead and save our script, and let's clear the workspace. So we will do a clear command and CLC. Now, if we open our script back up, and see now we're in the math section. If I do the run section, we'll see that we get an error. It says undefined function of variable A, because A doesn't exist. Our script defines it, but we're in this math section, so it's telling us that, okay, just run this section, disregard the previous 2 sections. So what we want to do in this case is we want to actually hit the run. So the run is going to run from the top to the bottom. So by selecting run, we'll see that we now have in our workspace our A, B, C, D, product, and sum. And on our command window, we have our example. Now, this example is telling us that that's the script that we ran, 𝐒𝐨𝐥𝐸. And our A is equal to 1, B is 2, C 3, D 4. Our sum is 10, and our product is 24. So now we were able to create a script, we saved the script, and we were able to run the script within the script editor. Now, another thing we can do to run this, so now we have it saved, I can close. And if we do a clear CLC, we'll clear our command window, clear our workspace. I can double click this example.m and it'll bring up the same exact script I just created. And I could then go ahead and run it from here. However, another way I can run it is by simply calling, and I'll close out of the script just to show you that you can run it this way, just by typing in example, and if I tab, it'll fill it in, because when I type in 𝐒𝐸𝐴MPL, there's no other option in terms of MATLAB command or script in the directory within the current folder. So if I go ahead and press enter, it'll run this example, the script that we just created, directly from the command line. And we can see that by we have our A, B, C, D are all displayed, our sum and product are displayed, and the values are all displayed within the workspace. Now, if we do a clear and we'll CLC, I'm going to go select the documents as my directory, and I'm going to try and run example again. Now, when I try it again, you'll see that it still picked it up. It knows that to search within this directory, within the MATLAB directory, to go there. That's because my MATLAB folder is still selected. Now, if I go to, say, Adobe folder and select this and try and clear CLC, try and run example again, we'll see that it still runs, and that's because I need to actually select a folder. But if I go, MATLAB folder is still selected. So if I were to go and navigate to a different folder per se, if I just go to my documents and say select folder, I can still run my MATLAB because it knows that when something's in my MATLAB, and this may be if you have an older version of MATLAB, if you go to a different folder, you may have to make sure you navigate to the MATLAB directory. However, in 2017, if you select a different folder, your MATLAB is always selected. So as long as you have your files in this directory, you'll be okay. But this is various ways that you can run your scripts. So you create a script, you type up a set of commands you want to run. You can run it from the command window, you can open the script and run it itself. Or if there's certain sections you want to run, you can open it up and run specific sections. And so that is an example of the MATLAB script editor. Welcome to the Home, Plots, Apps tab lecture. In this lecture, I'm going to show you some of the different tools and commands that are located within MATLAB on the Home, the Plots, and the Apps tab. So from the Home tab, we've already covered several of the different commands. So we've already created a script. We know that this creates a new script. Within the New command, this is where we can select either a script, live script, function, example class, figure, so on, and an application. From the Open, we can open, if we click on the Open, it'll bring up this dialog box where we need to go out and we can select a MATLAB file. And if we can narrow it down to we want a code file like a .m or .mlx, or a Simulink file, a Simulink project, code generator files, or we can just say all MATLAB files. If we go to the import data, this is where we go and we select the recognized data file. So we can have MATLAB data file, .mat, which we'll cover later, or we can have images or audio files or other different types of files we can work with. And so we'll hit cancel there. And we also have this save workspace where we can take all the variables in our workspace and save them to like a .m, a MATLAB data file. And we also have variable editing features. So if we click on the new variable, we can create a variable and we'll name it A. And we'll make it a value of 54. And we'll say, okay, so now if we go here, 54, right click, we'll say rename. Go to the value of A. So now we have the variable A, 54, without having to type anything on our command window. However, we can also do that just by saying lowercase a is equal to 36. And we'll suppress the output. We also have the open variable. So if we pull down, we have two options, A or capital A. So we'll pick our lowercase a, and instead of 36, we'll make it equal to 125. And we click out and we close out. Now our lowercase a is equal to 125. Another thing we can do is this clear workspace. If we right click down, we can clear all functions of variables, or we can just click on the clear workspace. And this is telling us that we're going to take all the variables in our workspace, which currently we have two, A and capital A, and then we're going to remove them. So we'll click on OK. And now we just cleared all the variables from our workspace. We can also do the clear commands, where this is the same as running the CLC command, where all the commands in our window, it basically clears our command window. So if I hit clear commands, we'll say OK. Now we'll see that our command window is blank, that we have erased everything that we put on there. We also have an analyze code, where if we have MATLAB or .m files, we can analyze them. we have a run-in time. This is where we can run a MATLAB code file, a .m file, and it'll time it to see how long it takes to run that file. This is typically used when you're processing a lot of data. You'll use this. We have the Simulink button, where if we click this, it'll start up and generate Simulink, where it'll bring up the Simulink start page, where we can go and open a recent project. We have the chirp wave, or we can create a brand new project, blank model, library, and a lot of different options for our Simulink. And they have examples. We can go here and select different Simulink examples they have already provided. And we can go to layout. This is where we can change and customize the layout. I typically leave mine to default, but if you want to change the way that your windows are oriented, go ahead and you can go in here and change those around. And in preferences, this is just settings you can set within MATLAB. So you can go through and just kind of it's all your preferences, where you're located, how you want your date and time format, and a whole lot of other things. Cancel out of there. And we can set our path, where I'm just leaving everything to default. This is where our different MATLAB functions are located. We can add folders to say, okay, wherever we want a search path. So within a search path, if you have, since we have the C users, Jordan documents, MATLAB as a search path, any file that I put in this path I can call that function from anywhere else. So I can create more of these on different drives or wherever else I have in my computer, but I typically just leave this to default. However, if you have a lot of MATLAB files that you're using and you have them in a located directory, you can then add that folder, and now you have access to all your different MATLAB commands that you've previously created. And you can browse the add-on. This is, if you want to work with hardware in MATLAB, you can use this. In this course, we're not going to be working too many with these add-ons, but this is where if you want to program your microprocessor, FPGA, or anything of that nature, you would do that from within this add-ons section. And they have a help, which you can go through and get help on all the different commands and everything else. Same with the community, request support, and MATLAB questions, access on demand. And if we go to our plots, this is where we can actually, by clicking on different values, we can plot them. Now, to show you right now, they're all grayed out saying there's nothing we can plot. It's telling us we need to select a variable to plot. Well, I need to create a variable that I can actually plot. So we'll do that by, we'll say, create a variable called x, make it equal 1, increment by 5 up to 100, suppress it. So now we have an x value that goes from 1 to 20. And if we double click, we can see it goes 1, add 5, so 1, 6, 11, on up. And we'll create another one called y is equal to 1, starts at 1, goes up by 6, and goes up to 120. Press that output. So now we have two variables, x and y, and they're both value of 1 by 20. So if I select x, I can go ahead and plot x, and everything that's highlighted are all the available plots that I can do with x. So it's showing me plots for x. I can select all plots, and now these are all the available plots that MATLAB has. However, given the format of x being a 1 by 20 double, I can't do a surf or a surf C plot. However, I can do a feather or a compass plot, as well as just a regular plot, area plot, bar plot. And if you hover over them, the little help bar comes up and gives you an example of what you need to do to create that. So when I select the plot, it generates a figure that has just the plot of x, which all it is a value that starts at 1 and increments by 5 up until 95. So we just get a straight line. And if we look on our command window, we can see that if we just type in plot x, we'll generate the same exact thing. So if I would go here and type in plot x, enter, I generate the same exact figure just by clicking on the actual plot itself. It just can be a little quicker. Now, where this can be useful is if I select x and y by holding down the control key, now it gives me options of plotting both x and y on the same plot. So I can do this plot as multiple series. And if I select that, you'll see that it brings up this plot that now has our x and y, which are the same line, just they start at the same point, but there's a different slope. So you can see we have our blue and our red lines. And also, our command tells us if we type in plot y, comma, display name, comma, y, comma, hold on, plot x, this is what we need to type in to pull up this type of plot. And so by doing that here, by clicking on these, it just becomes a quick and easy way that we can create quick plots. And if we wanted to put this in a script, we would then copy what is displayed here in the command window and paste that into our .m, our script file, and then we can generate this at any point in time whenever we wanted to do that. And so that is kind of the plots tab, the different things that we can do. And also with the apps tab, finally, we don't have any apps with just the standard MATLAB and standard Simulink license. There are no apps we can use. However, if you download different toolboxes or additional toolboxes, you'll find that you will have apps available here, and these are going to be strictly based upon what toolboxes you downloaded. And so that is the Home, Plots, and Apps tab for the MATLAB environment. Welcome to saving and opening workspace variables within the MATLAB environment. In MATLAB, we can create these variables either from the command line or from a script, and we know that they are shown and displayed in the workspace editor. Now, what we can do is take these variables and save them as an MAT or a MATLAB data file, and then we can open them to use later. So for example, let's just create a few variables. So we'll create A, which will make equal a vector starting from 0, incrementing by 5, and going to 100. Semicolon to suppress the output. We'll make our Z equal to a variable of 45. Put a semicolon to suppress the output. And we'll make another variable, we'll call it G, which is equal to a character array that will say this is a character array. We'll end that. And we'll also have another variable we will call, we'll just call this example. And this will be equal to from 0, incrementing by 0, 1, and going to 45 and suppress. So we have 4 different variables. We have our A, which is a 1 by 21 double, a vector. Our example, which is a 1 by 4,501 double. And our G, which is a character, saying this is a character array. And Z, which is a 1 by 1 double, which is equal to 45. And so in order to save these, there are several things we can do. We can select any one of these and save them as a MATLAB data file. So we are going to take and save G as a MATLAB data file. So right-click, select the variable in the workspace, right-click, and select the Save As icon. And from within here, we're going to give it a name. So we can save it as a MATLAB script, all files, but we want a MAT file, which is a MATLAB data file. So we'll give it a name. And we can name it G, which would make sense in this case, but obviously that variable name doesn't really descript. So we'll just put G variable, G underscore variable. So we'll hit save, and this is going to save it. It should show up in our current folder as a MAT file. So if we select it, you'll notice down here in this little icon information, so we can select these other icon. So if we select the example.m, which is a script, it displays down here saying this is a comment, display variables, math, and these are just the different sections inside our script itself. But by selecting this G underscore variable.mat, it gives us a little bit of information about it, such as the name, which is G, and the value, this is a character array. Now, what also I can do is I'm going to save my workspace, and that can be done by selecting this button, this Save Workspace button. By clicking on it, it's going to take all of the variables, my A, example, G, and Z, and save them into a single MAT file. So I will call this workspace, and we'll hit save. And as soon as we do that, you'll see that we now have this gvariable.mat and this workspace.mat. So if I select the workspace.mat, we'll see that what is shown down here, A, Z, example, and G, is exactly what's in our workspace. So we can get rid of everything in our workspace by do a clear and CLC to clear our commands. So now our workspace is completely empty. There's nothing else in there. So what we want to do is now we want to open our saved variable. So first, let's open this gvariable.mat. We can right click and select load, and that will bring up the command that if we were going to do this from the command window, we would use the keyword load, and then in the brackets place the actual variable, the file itself, the g_variable.mat. So if you were going to have this happen inside of your script, you would want to copy this load and everything inside the brackets there and paste that inside your script so that this G variable would now be accessible inside of your workspace. Another thing you can do is just double click. So it's workspace.mat. If you double click, it opens it. So I double clicked it and then the keyword load workspace.mat appears. So now we have all of the variables in our workspace that we previously had saved. And this can be useful for various different applications. If you're creating scripts, and instead of calculating, if you're doing like image processing or some sort of algorithm that's very computationally intensive and you keep having to redo it because you're trying to iterate through your script example, these mat variables are a great place to put them. So you can save the variables in there because doing the load command is a lot faster than running the calculations. And so that is how you can save and open workspace variables within MATLAB. Welcome to the demonstration lecture for Project 1, Restoring Your Workspace. On the screen, I have the workspace is restored. You have downloaded the workspace.mat or the MATLAB data file, and when you restore this MATLAB data file, you should see the following variables in your workspace. You should have variable A, which is equal to the value of 1. It's a double precision value. Variable B, which is a single precision value and equal to 23.4568, and base, which is equal to a character array that says this is a character array, and the variable flight time, that is a 1/41 double precision value. There's a vector, and it counts from 1 and goes up to 121. And then you should have a matrix, a 6x6 double precision matrix, variable called light, that is equal to a matrix that has the following values: 35, 3, 31, 8, 34, and the following columns you can see on your screen, you should have all of these values. So when you successfully restore this workspace.mat file, you should see all of the following in your workspace, and you should be able to use the commands in the command window to verify you're getting the same values that I'm displaying here. So that is a demonstration of how to restore your workspace in MATLAB. Hello, and welcome to the step-by-step solution for Project 1, Restoring Your Workspace. So you've downloaded the attached workspace.mat or the MATLAB data file, and I'm going to show you how to step-by-step get this MATLAB workspace file and load it so that all the variables show up in your workspace. There are several ways you can do this. One, you can double-click on the workspace.mat. Double-clicking on the workspace.mat pulls up in the command window the load and then the parentheses the workspace.mat, and that tells it to load this file. And if we look in the workspace, we'll see that we have a variable A, which is the value of 1. It is a double. Variable B which is a value of 23.4568 and is a single precision. We have base, which is a 1 by 25 character, and if we double click on it, it tells us that it says this is a character array. And we have flight time, which is a variable that is double, 1 by 41, so 41 values, a vector. And we have a variable light, which is a 6 by 6 matrix. If we double click, and this is a double precision value as well. Now, the other way I'm going to show you, we can type this command in directly by, if I highlight, we'll do a copy, and we'll do a CLC, and we'll clear our workspace by typing in clear. We get rid of all the values from our workspace. Now we'll say paste, so we can just type in the command workspace.mat and hit enter, and we'll bring up the same exact thing as we did before. We have our A, B, base, flight time, and light variables. And so that is step-by-step how you can restore your workspace from a MATLAB data file or a .mat file. Congratulations on completing Get Started with MATLAB and Simulink and Intro for Beginners. If you haven't already, please message me and let me know what you are using MATLAB and Simulink for, as well as what type of MATLAB topics interest you. And now that you've completed this course and have an understanding of what MATLAB and Simulink can be used for, if you have any ideas or what you're wanting to use MATLAB and Simulink for, please let me know. I'm interested to know what topics interest my students. And also, now that you've completed this course, be sure to check out my Learn MATLAB and Simulink Programming course. It builds off of this course to increase your knowledge and skills in the MATLAB and Simulink area. And now that you've completed this course, you should have the MATLAB and Simulink installed on your computer. So taking the Learn MATLAB and Simulink Programming, we're going to learn how to write scripts, how the MATLAB, all the different functions in MATLAB, all the various commands, as well as using scripts and modeling real-time systems in real life using Simulink, and how to analyze. Welcome to Get Started with MATLAB and Simulink, an Intro for Beginners. This course is designed to teach complete beginners how to get started using MATLAB and Simulink. Now I'm going to tell you a little bit about me. My name is Jordan Chrisman, and I'm the instructor for this course. I have my graduate degree from the University of Dayton in electrical engineering with a focus on embedded systems, where I typically worked with FPGAs, microprocessors, and any type of logic system with low-level voltages. I am an avid Pittsburgh Steelers fan. I try to watch every single game that is televised, and so if the game is on, you most likely can figure I'm watching it or catching updates on my phone or online. I use MATLAB and Simulink every day at work, and I have found it to be a very powerful and extremely useful tool. And I like using it so much that I enjoy teaching about it, and I want to be able to teach you how to use MATLAB and Simulink and show you the powerful capabilities that this tool has. If you're working on any cool projects using MATLAB or Simulink, or if you have any cool project ideas, absolutely let me know. Like I said, I enjoy doing this, and so if you have any cool ideas, let me know, because I'm always interested to see what other people are doing or how they're using MATLAB and Simulink. And if you have any questions regarding MATLAB or Simulink, don't be afraid to ask. Just send me a message or a question or an email and ask me any type of questions you have about MATLAB or Simulink. In this course, let's talk about what you're going to learn. This course covers introductory topics relating to MATLAB and Simulink. And the big things you're going to get, you're going to learn how to get MATLAB set up on your computer. So we're going to show you step by step